So in section 2.2, we're getting more delving deeper into those word problems. So we're doing creating and solving equations. We're going to see how we're really pulling out of words here, pulling the equations right out of words. So the essential question is, how do you use an equation to model and solve a real-world problem? And there's actually going to be no vocab for this lesson because it's all coming right from the words that we already know from English. So we're going to jump right into, the title of this section is Writing Expressions. So writing expressions from words. So for number 1, we've got the sum of 11 and a number is 19. So we always read from left to right. So as we read, we can write out the expression. But we've got to first understand what sum means. So if you look back in the chart that we had cut out and put in section 2.1, the chart shows that sum is the addition operation. So the sum of 11 and a number, okay, we don't know what that number is. So anytime we don't know what the number is, we're going to just use a variable. We're just going to call it x. Okay, so the sum is addition of 11 and a number is, this is kind of the weird one, is always going to be our equal sign. That's always going to be where we write out our equal sign to 19. Okay, so 11 plus x is 19. So all we're doing right now is writing them out. We're not going to solve. I know you guys could solve that one out. So the difference, this is number 2, the difference, if we look back in our chart from 2.1, this is subtraction, difference between a number, we don't know what that number is, so that's x, and 15 is, okay, that is always going to be our equal sign, 30. Perfect. So the difference, subtraction, between a number and 15 is 30. So basically, as we read every word, we're writing into this equation. The next one, 1/5. 1/5, that is actually a number, and that's going to be represented as a fraction. 1/5, a number. Remember, a number means that we don't know what that number is, so we've got to represent it as a variable. And remember when it doesn't show an operation? Just multiplication. So 1/5, a number, plus, right, we've got plus here, that means addition, plus 1, okay, is always going to be our equal sign, is 6. Perfect. So that's all we're trying to do right now, is pull out everything out of the equation, pull it all out, put it into an expression, and of course I know you guys would be able to solve these problems as well from section 1.1. Okay, so I'm going to erase my work, so if you still need it, go ahead and pause the video so you can get it down. But I'm going to erase my work so that I can give you guys some practice problems of your own. So I'm going to have you guys practicing the exact same thing. Just going to change up the numbers to make sure that you guys are all good to go. I'm just changing up the numbers here. So what you're going to be doing is you're going to be completing this on the left-hand side, and you are going to be just writing out the expressions. Make sure you title this section, but writing out the expressions just like we just did in the last 3 examples. That's all I want you to do. All right? So we've got, let's go 2/3, 2/3, a number plus 6 is 10. Okay? The difference between a number and 12 is 27. Alright, and the sum of 6 and a number is 31. Okay, so pause the video and complete these on the left-hand side of your journal. You are writing out an expression. Okay, if you're you're back with me, I'm assuming you've wrote out all these expressions. I'm not going to give you guys the answers because I want to make sure you guys can do them on your own. So I'm just going to erase this. If you still need it, just pause video. And we're still going to be under the same section right now. We're still just going to write some more problems, but we're going to be doing ones that are a little bit different. Okay. So right here, this says the price S. Okay, so we've got a variable, the price S of a pair of shoes plus 5% sales tax. And remember, we're still writing an expression just like we did. And we're trying to see how much is that actually going to cost. So we're writing an expression for the total cost. Okay, so we have the pair of shoes. Well, that's obviously, you obviously have to pay that if your shoes are $75. You have to pay the $75 plus, that's our addition, plus 5% sales tax. Now, remember, sales tax depends on how much the item is. You're obviously going to pay more tax on a car than you would like an apple. So the tax depends on how much it is. So 5%, anytime that you see a percentage, we've got to change that to a decimal, right? So we've got to move our decimal over. So right now it's just a regular 5. Our decimal would be right after the number. And we always move it to the left twice, put a new decimal, and add in a 0. So 5% becomes 0.05. Anytime you have a percentage, you've got to change it. So plus 0.05. But remember that sales cost depends on how much it was. So you've got to multiply it by the original sales cost. It's 5% of the cost. And this expression here would represent your total cost of your shoes. So if it was $100, so let's say for example your shoes were $100, it would be $100 plus 0.05 times 100, which will give you $100 plus 5, which will give you $105. So just remember, it's not always the actual price of the shoes that it shows. You gotta include sales tax. So you would end up paying $105 for it when you walked out the door. Alright, so this should have all been completed on your right-hand side of your journal. I'm going to give you a practice problem that I want to see you guys do on the left-hand side. So here's a problem I want you to complete on the left-hand side. It's still under writing expressions. It says the original price P, that's our variable, of an item, less, attention to that, not plus, less a discount of 20%. So this is when your shoes are marked down. We're saying there's 20% off. And there's no sales tax in this problem. So pause the video, complete this on the left-hand side, and come back when you're done. Alright, so if you are back with me, I'm assuming you just completed this problem on the left-hand side of your notebook. And we are now going to be moving on into solving equations. So we're getting past just writing them, we're actually going to start solving equations. And you're going to need your workbook for this. We're going to be cutting a couple things out of your workbook. So if you don't have that, go ahead and grab your workbook. So in your workbook, you want to turn to page 58. So page 58, you are cutting out problem number 5 on the very top. So you are cutting out problem number 5, and you are going to put it on the right-hand side of your journal. We're going to work it out on the right-hand side together. So if you need some more time to do that, you can pause the video to get that done. We're going to start working it here. So I'm just drawing out the diagram that they have in the workbook. Alright, so we've got this rectangular garden, and the problem says you should have it right in front of you. You should have it pasted in on the right-hand side. The problem says a rectangular garden is fenced on all sides with 256 feet of fencing. The garden is 8 feet longer than it is wide. Find the length and the width of the garden. So W is obviously used to represent the width. That's why it's a W, not an L. And so this is the length, because the length is 8 units longer than the width. So when we're talking about 256 feet of fencing, it's talking about the outside, right? It's talking about the fence that's surrounding the garden, which is the outside. Now, if we think about what that outside is in terms of mathematical terms, it's not the area, it's not what's inside of it, it's the outside, which would be the perimeter. So there's a couple ways to get the perimeter. You are basically adding up all the sides. So there's 2 widths, so 2 widths, plus 2 lengths, right? Because you're adding all the sides together, and that will give you the perimeter. In this case, our perimeter is right here, because this is the length of the whole outside of the garden, so 256. So we're going to leave units off right now because they're all feet, feet, feet. Perfect. So let's look at what our width and our length are in our case, in particular with this garden. So we have 2 times the width. Well, the width is just W, so we're good there. But for our length is W plus 8. So W plus 8. Okay, so we've got 2 width plus 2 length is equal to, and it's always going to be equal to that 256. Right there. Perfect. So we're going to have to work with this equation, do as much as we can to it. So the first thing we're going to do is we're going to distribute the 2. And we will get 2W plus 2W plus 16. So 2 times W is 2W. 2 times 8 is 16 is equal to 256. Right, so 2 times W, got the 2W. 2 times 8, got the 16. Okay. And we got to combine like terms. So we've got all of our W's. We're going to add them together. We have 2 W's here and 2 W's there. When we add them, we get 4W plus 16 is equal to 256. Alright, we're going to try and solve out for that W now. So we want to get the W by itself. Just like I did before, I did box it before. I like to keep that term all by itself. I like to keep it in a box. So I'm going to, first thing I want to do is subtract the 16. 16 minus 16 is just 0. We don't need to show that step though. So 4W is equal to 240. 256 minus 16, we get 240. And I'm not going to box it again because it's now all by itself. It's on its own side of the equal sign. So the last thing we have to do is think, well, this is multiplication happening between them. We got to use the inverse. We got to use division. So we're going to divide both sides by 4. And we will get W is equal to 60. Okay? All the units are feet. So we do get our units of feet down there. So you've got width is equal to 60 feet. But the problem is asking us to find the width and the length. So we also need to find that length here. So let's look. Our length is W plus 8 feet. Well, we have W now. W is 60. So if the length is W plus 8, the length must be 60 plus 8. Because W is 60, which just lets us know it's 68. And again, it's feet, feet, feet. They're all feet. So 68 feet. So we've got our length at 68 feet there. And we did go ahead and solve that problem out. Okay, we are going to do one more because I know that there's a lot of steps, a lot of work, a lot of stuff happening. So we're going to do one more together. Then you're going to be able to do one on your own. So I'm going to go ahead and erase this. If you still need it, just pause the video. Okay, you guys are going to need to cut one more, actually 2 more out of your journal right now. I'm going to have you guys cut out from page 60. Right, you're on page 60 now. You're going to cut out number 7 and number 8. Number 7 and number 8. Number 7 is going to be pasted on the left-hand side. You guys will be doing that one on your own in just a minute. Number 8 is going to be pasted on the right-hand side. We're going to do that one together right now. So number 7 on the left, number 8 on the right. If you need some time to do that, go ahead and pause the video. Okay, so we're doing number 8 together. So number 8 says that a veterinarian is changing the diets of 2 animals, Simba and Cuddles. Simba and Cuddles. Okay. Simba currently consumes 1,200 calories per day. So Simba's got 1,200 per day. 1,200 calories per day. And that number will increase by 100 calories per day. So I'm just going to put plus 100 per day. And Cuddles currently consumes 30 calories a day. So 30 per day. But let's see what's happening to Cuddles every day. That number will decrease by 190 calories. So decrease by 190 every day. The patterns will continue until both animals are consuming the same number of calories each day. And how many days will that be? So that key word there is same, right? Same. What does that same mean? That means that they have to be equal. They have to be the same. They've got to be equal. So we know we're going to have basically a big equal sign in between them. We've got this big equal sign. Okay, so we've got to write 2 expressions here and set them equal to each other. One for Simba, one for Cuddles. So what we're going to do is we're going to define our variables. We are going to let n be, you could just as easily use x, that's fine, but let n be the number of days. That's what we're truly trying to solve for, right? How many days is it going to take until they are eating the same amount each day, until they are equal? So n is going to be our variable, it's going to be the number of days. So let's see, Simba's got 1,200 already. Simba's starting off with 1,200. Okay. 1,200, and then they're adding 100 every day. So every day, so we have to multiply that by n, adding 100 every day. Okay, how about Cuddles? Cuddles has 30 right now, and they are subtracting 190, but they don't just subtract it once, they're subtracting it every day. Okay, and now we've got to solve out for n. We've got to solve this expression. This is our equation that represents our situation, and we're going to solve that out for n. So there's multiple ways you can do this. There's multiple things you can move at one time. I don't ever really like subtraction, so that's the first thing I'm going to move. I'm going to add 190n, add 190n to both sides. Anything I do to one side, I have to do to the other. 190 and 190, those cancel out to become 0, and we get 1,200 plus 290n is equal to 3230. Okay, 1,200 plus 290n is equal to 3230. Well, all of our variables are on our left-hand side of our equation now, so we've got to get all of our numbers to our right-hand side, so we've got to move that 1,200. It's addition happening, so I'm going to have to use subtraction to cancel it out. Subtraction. And 1,200 minus 1,200, that cancels out to get a 0. You get 290n is equal to 290n is equal to, alright, let's do the math here, 2030. And then we are going to try and get n by itself, all alone. You don't see any operation in here, but it is multiplication, 290 times n. You use the inverse of that, which is division. So we're dividing both sides by 290. 290 divided by 290, you get 1. So we get n is equal to, and it turns out to work perfectly, to 7. So what did that mean? What did we just solve for, right? What did we even do? So the number of days that it takes to get Simba and Cuddles eating the same amount of food is 7. So the number of days is 7. Awesome. Okay. So the very last thing for this entire lesson is you guys are going to need to complete number 7 on the left-hand side of your notebooks. That's the very last thing for this lesson. Once you complete number 7, you are good to move on to the next lesson.